Okay, for this next part, I want to introduce a new way of writing negative feedback systems. So far we've been using the system we learned at the very beginning, where you have an integrator and a sensor, and then effectors coming from that. This is a similar system, but let me redraw parathyroid hormone using this new system. So we're going to talk about, if this is our parathyroid gland, we're going to say that what it does is secrete PTH. And then what we want to know is what tells the parathyroid gland to secrete it or not secrete it. We know that calcium, blood calcium bound to that G-protein coupled receptor, which then caused the release of internal calcium into the cell, which suppressed release of parathyroid hormone. So we know that calcium, I'm going to put a little minus here. Calcium acts to reduce how much PTH this secretes. So this is a way of saying that calcium stops the parathyroid gland from doing what it does. And then we can draw the feedback loop that the parathyroid hormone, we could do several things here. We could say it goes to the kidneys and the bone, which increases breakdown. And the kidneys, where we get more reabsorption and conversion of vitamin D, both of which increase the amount of calcium in the blood. So the idea is that when there's calcium in the blood, it stops this process. When calcium in the blood gets low, it doesn't suppress this, which causes parathyroid hormone to be secreted, which then increases the amount of calcium in the blood. So this is just another way of writing a negative feedback loop. Now, this will hopefully work a little better for the next thing I'm going to talk about, which is insulin and glucagon. All right, insulin and glucagon are two hormones, both of which come from the pancreas in its job as an endocrine organ, that are involved in regulating blood sugar. So you may be familiar with insulin. Most people are more familiar with that because of its role in diabetes. Type 1 and type 2 diabetes involve problems with insulin. In type 1, the pancreas doesn't produce insulin, and in type 2, at least early in type 2, you start with the body not responding to insulin properly. But in both cases, it messes with your blood sugar. So there are actually two different groups of cells in the pancreas that secrete these hormones. We're going to start with the alpha cells. And alpha cells secrete glucagon. Now, the hormone glucagon, its primary effect is on the liver. What it does in the liver is increase glycogen breakdown and release of glucose. So part of the job of the liver is to store glucose in the form of glycogen. Remember, that's that polymer of glucose. So the liver takes up glucose, puts it together into glycogen, and holds on to it. And then, when it's needed, the liver can break down that glycogen into glucose and release that glucose into the blood. So glucagon tells the liver to do that. Increase the breakdown of its glycogen and release that glucose into the blood, the effect of which will be, do this over here, to increase blood glucose. So alpha cells make glucagon, which tells the liver to break down glycogen and release that glucose into the blood, which increases blood glucose. Now, to complete the negative feedback loop, blood glucose suppresses the alpha cells. So imagine you start with low blood glucose. That means we don't have this suppression, which means the alpha cells are allowed to make glucagon. Glucagon tells the liver to release some of its glucose, which raises the blood glucose level, which then tells the alpha cells to stop making glucagon. So there's our negative feedback loop. If blood sugar gets high, it suppresses the alpha cells, so they don't produce as much glucagon. If blood sugar is low, if we take this away, the alpha cells are allowed to make glucagon. So that's a simple negative feedback system. That's actually a lot like the parathyroid hormone system. But that's only one side of this thing. Now let's look at the other hormone. So in the pancreas, we also have beta cells. And beta cells' job is to secrete the hormone insulin. These are both protein hormones, but insulin has a different effect. Insulin acts primarily on muscle and fat cells. What it tells them to do is to increase uptake of glucose from the blood. So insulin tells these muscle and fat cells to pull glucose out of the blood, take it in, actually turn it into glycogen, or use it for energy. That is going to reduce blood glucose as these muscle and fat cells take the glucose out of the blood. And to complete the negative feedback loop, high blood glucose tells the beta cells to secrete insulin. So now we've got these two negative feedback systems tied together since they're both changing the same thing. So let's trace this system through. Let's imagine that our blood glucose level is getting high. So high blood glucose, what does that do to the alpha cells? Well, blood glucose suppresses them, so the alpha cells will not produce glucagon, which is good, we don't want them to. But that high blood glucose activates the beta cells. So the beta cells make insulin. The insulin tells the muscle and fat cells to take some of that high glucose out of the blood, which brings blood glucose back down. Lowering the blood glucose will stop activating the beta cells. But what if we lower it too far? Well, if we lower it too far, then it stops suppressing the alpha cells, so the alpha cells start making glucagon. Glucagon tells the liver to start releasing more glucose, which makes the glucose levels go back up. As they go up, they tell the alpha cells to stop making glucagon. If they go too high, then we activate the beta cells again, and they make more insulin, and that tells the muscle and fat cells to take glucose out of the blood. Now this sounds like we're always going too high or too low, and that's not really what it is. What we try to end up with is a level of insulin and or glucagon enough to keep the blood sugar steady. Now it does mean that, say, if you go out and eat something and you start raising your blood sugar, we will readjust these hormones to then take that extra glucose back into muscle, to take it into the muscle and fat cells to bring the glucose level back down. And if you fast for a while, then as that falls, you'll make less insulin and more glucagon, which will then bring your blood sugar back up. So this is a two-sided negative feedback system. Same thing being monitored, but two different integrators which make different effectors, if you want to think of it that way. And there's a couple of other ways in which these interact. One of them is that insulin suppresses alpha cells. So if the beta cells make insulin, not only is that insulin telling us to take glucose out of the blood into the muscle and fat cells, but that also specifically tells the alpha cells, I'm making insulin now. I'm getting our blood sugar down. Don't make glucagon. So that's one way in which we have another interaction here. And we have something else that comes in from outside. Epinephrine activates alpha cells. So you can have this normal system going on where we're keeping our blood sugar normal with a balanced level of insulin and glucagon. And then epinephrine comes in. We see the hungry bear and our sympathetic nervous system goes nuts and we get an adrenaline release. And that epinephrine tells my alpha cells, to heck with worrying about blood sugar right now. Make glucagon and tell the liver, give us sugar because we're going to need it to run from this bear. So now we have this two-sided negative feedback system with an outside influence that also influences this. Now a question that sometimes comes up here is, So which of these wins? If I've got all of these talking to the alpha cells, I've got epinephrine saying, make more glucagon, and blood glucose saying, no, don't make more glucagon, and insulin saying, no, don't make, who wins? The answer is, it's all of them. It's all of these things having an influence, and it's just who's stronger at any given moment. That is what's going to determine how much glucagon I make, or how much insulin I make. So, this is still a negative feedback system, but a little bit more complicated. It's kind of a two-sided interactive negative feedback system. Now, hopefully that's comprehensible. Now our problem is, actually, let's take a moment. If you say you have type 2 diabetes, so in type 2 diabetes, your body doesn't respond to insulin. We don't exactly know why, but let's see how that's going to mess with this. Say my blood sugar gets high. Normally, a high blood sugar tells my alpha cells to stop making glucagon, which will still work. But it also tells my beta cells to make more insulin. That insulin is made, especially early on in type 2 diabetes. But here's where the problem is. The muscle and fat cells don't respond to the insulin. If they don't respond and they're not taking in that glucose from the blood, then we are not lowering blood glucose, and blood glucose can continue to be too high. High blood glucose over time can cause damage to a variety of things. Now, in type 1 diabetes, the problem is my beta cells aren't making insulin, but it's kind of a similar effect. In fact, in type 1 diabetes, I may not have beta cells. They may have been destroyed. So, in any case, that's the insulin and glucagon system, a sort of simplified version. For the last one, we're going to talk about some important glands, the hypothalamus and pituitary, which kind of run the whole rest of the endocrine system, and how some of what they do and how they interact.